Black holes sound like something cooked up by a sci-fi writer with a taste for melodrama. An object so dense that not even light can escape. Reality, as it often does, went one better. These cosmic vacuums are not only real, they are casually shaping the universe while laughing at the laws of physics we thought were unbreakable. If the universe had a set of secret bosses, black holes would be the kind that show up with no warning and one-shot your character. Let us start simple. A black hole begins life as a star, a really big one. Stars are basically nuclear reactors held together by gravity. They spend their lives balancing a delicate tug-of-war between the outward push of nuclear fusion and the inward pull of gravity. When a massive star runs out of fuel, the balance collapses. Literally, gravity wins, crushing the core until matter collapses into a singularity, which is a polite word for a place where physics waves the white flag and says, "Yeah, I am done." Around that singularity is the event horizon, the point of no return. You cross it, you are gone. No signal, no escape, no refunds. Now, people like to imagine black holes as giant cosmic vacuums that roam the galaxy, slurping up planets like they are spaghetti. In reality, black holes are surprisingly polite. They only consume what wanders too close. If our sun magically turned into a black hole of the same mass, Earth would still orbit it just fine. Granted, we would all freeze and die because sunlight would vanish, but at least our orbital mechanics would stay predictable. Here is where it gets weird. Black holes bend space and time to an extreme degree. Einstein predicted this with his general theory of relativity. The idea is that gravity is not a force pulling things together, but the curvature of spacetime caused by mass. A black hole is mass on steroids, so the curve is more like a whirlpool. Light itself cannot climb out once it gets too close. This is not metaphorical. It is geometry playing bully. You might be wondering what happens to someone falling into a black hole. Scientists call this process spaghettification, which is both hilarious and horrifying. As you approach, gravity stretches you vertically and compresses you horizontally. Essentially, you become cosmic linguine. Your head experiences a different gravitational pull than your feet. The tidal forces tear you apart long before you even reach the singularity. It is like being destroyed by geometry homework. Yet, black holes are not just cosmic garbage disposals. They are also engines of creation. Around supermassive black holes, the ones millions or billions of times the mass of our sun, matter does not always fall in. Sometimes it swirls around in an accretion disk, heating up to insane temperatures and blasting out jets of energy that can stretch across galaxies. So, ironically, these objects famous for swallowing everything are also some of the brightest beacons in the universe. Quasars, for example, are powered by ravenous black holes at the centers of young galaxies. Imagine a flashlight so intense it outshines every star in a galaxy combined. That is a quasar, powered by an object that is supposed to be invisible. The universe has a great sense of humor. And about that invisibility problem, how do we know black holes exist if we cannot see them directly? We watch their effect on their surroundings. If a star is orbiting an invisible point, or if gas is being flung out at near light speeds, odds are a black hole is at work. The Event Horizon Telescope gave us our first direct image of a black hole in 2019. It looked like a blurry orange donut. People expected high-definition science fiction glory, and instead got a cosmic pastry. But that fuzzy ring was proof that Einstein was right, and that humans can aim radio telescopes across the globe in perfect sync just to spy on the ultimate cosmic diva. Hawking radiation is another curveball. Stephen Hawking proposed that black holes are not completely black. Thanks to quantum effects near the event horizon, black holes slowly leak energy. Over unfathomable timescales, they evaporate. This is where quantum mechanics and relativity start arguing like an old married couple. One says nothing escapes, The other says tiny particles can sneak out. Both seem true, and reconciling them is one of the great puzzles of physics. Speaking of puzzles, there is the information paradox. Physics says information about a system can never be destroyed. But if you toss something into a black hole, it looks like that information is gone forever. Hawking radiation does not seem to carry it back out. So, does the universe lose track of what fell in? If so, the laws of physics break. That makes physicists twitch. Some argue information is preserved in subtle correlations within the radiation. Others think it gets imprinted on the event horizon like a cosmic hard drive. Nobody knows for sure. It is the kind of headache that keeps scientists awake at night and makes philosophy majors smug. Supermassive black holes sit at the heart of almost every galaxy, including our own Milky Way. Ours is called Sagittarius, a star, a beast about 4 million times the mass of the Sun. Thankfully, it is quiet. But in the early universe, these giants were much rowdier, gobbling matter and firing jets that shaped galaxy evolution. Black holes may be terrifying, but they are also cosmic architects. Without them, galaxies might look very different, or not exist at all. Even more exotic is the idea of primordial black holes. These would have formed just after the Big Bang, from tiny fluctuations in density. If they exist, they could explain mysteries like dark matter. Imagine the universe sprinkled with ancient, invisible relics, the size of mountains, but weighing as much as a star. It is possible, though we have yet to prove it. There is also speculation about wormholes. Some solutions of Einstein's equations suggest black holes could be linked to other regions of spacetime. A black hole paired with a white hole might form a tunnel, a shortcut through the universe. Convenient for science fiction, deeply unstable in reality. Any tiny disturbance would collapse the tunnel before you could even send your luggage through. So, while wormholes make for great movies, do not pack your bags just yet. Quantum gravity is the holy grail here. At the singularity, general relativity breaks down and quantum mechanics takes over, but we have no theory that unifies them. String theory, loop quantum gravity, and other contenders are all attempts to explain what actually happens in that central point. For now, the singularity remains a black box in the most literal sense. And here is the kicker. Black holes are not rare oddities. They are everywhere. Stellar mass black holes likely number in the hundreds of millions in our galaxy alone. Supermassive ones rule the centers of galaxies like cosmic landlords. Even intermediate mass black holes, once thought to be missing, are starting to show themselves. The universe is basically a black hole enthusiast club, and we are just catching up. Gravitational waves are another way we spy on them. When two black holes spiral into each other and merge, they send ripples through spacetime itself. In 2015, scientists detected these waves for the first time. It was the sound of the universe announcing two black holes had just danced and collided a billion light years away. It is cosmic gossip carried across time and space. These detections have opened a whole new way of studying the universe, letting us hear events that were previously silent. The more we study black holes, the stranger they get. They challenge our ideas of space, time, energy, and information. They force physicists to admit that our theories, elegant as they are still patchy, and yet these dark monsters also light up galaxies, inspire equations, and give us a glimpse of the ultimate rules of reality. Black holes are less like cosmic death traps and more like nature's way of telling us the syllabus is incomplete. So, next time you hear about one, do not think of it as an endless vacuum cleaner in space. Think of it as the universe dangling a mystery, a riddle written in gravity and light, daring us to solve it, and maybe laughing a little, knowing we are still stuck trying to understand what happens when you divide by zero. Black holes are often called the most extreme objects in the universe, which is funny because they manage to be both terrifyingly destructive and bizarrely productive. They annihilate anything unlucky enough to cross their borders, yet they also sculpt galaxies, launch jets, and illuminate the cosmos. It is like having a neighbor who occasionally burns down houses, but also throws parties bright enough to light up the whole block. Let us talk scale. A stellar black hole might be 10 times the mass of the sun. A supermassive black hole can weigh billions of suns. Wrap your head around that. One object so dense that you could fit an entire solar system inside the space its event horizon occupies, without the slightest chance of light getting out. And still, astronomers can measure its presence by watching stars whip around it at speeds that make fighter jets look like lazy kites. The orbits of stars near Sagittarius A star, for instance, have been tracked for decades. They zoom around an invisible anchor point with velocities that scream, "Something huge is here." When the Nobel Prize Committee wanted proof of black holes, these orbits sealed the deal. Watching those stars whip around nothing is like seeing a dog straining on a leash when you cannot see the owner. The owner, in this case, just happens to be 4 million suns, packed into a cosmic void. Now, if black holes are so good at swallowing, why do some of them produce those spectacular jets? The answer lies in the accretion disk. As gas spirals in, it gets compressed, heated, and magnetized. This chaotic mess channels energy into streams that shoot out along the poles. Some of these jets are thousands of light years long. To put that in perspective, a single jet could stretch across our entire galaxy and still have leftover distance to spare. The energy output is so colossal that it can outshine everything else in the host galaxy. And yet, none of that energy actually comes from inside the black hole. It is just the byproduct of the infalling material getting its atoms shredded on the way down. This irony never gets old. Black holes, the definition of invisibility, announce their presence by being some of the brightest sources in the sky. It is like a mime trying to stay unnoticed by setting off fireworks. But the deeper you look, the more the contradictions pile up. Time, for example, behaves badly near a black hole. To a distant observer, anything falling in seems to slow down, forever frozen at the event horizon. To the falling object itself, time feels normal until it ends abruptly. So who is right? Both, depending on your perspective. That is the kind of nonsense relativity specializes in. Time is relative, and black holes expose just how fragile our sense of normal really is. And then there is entropy. Black holes have a temperature and entropy proportional to the area of their event horizon, not their volume. That means their information content scales with surface area, not size. This odd fact led to the holographic principle, the idea that our universe itself might be described by information encoded on a boundary surface. In other words, we might all be living in a giant cosmic projection. Black holes, once again, are handing out existential crises like candy. Some theories go further, suggesting that black holes might actually be seeds for new universes. Picture this: collapse everything into a singularity, and instead of ending, it bursts outward into a new space-time bubble. To anything inside, that bubble would look like its own Big Bang, which raises the uncomfortable question, is our universe itself the inside of some ancient black hole? If so, the cosmic Matryoshka doll has no end. Reality is just universes all the way down. Black holes also play favorites with physics experiments. You want to test relativity? Watch how they bend light. You want to probe quantum mechanics? Study Hawking radiation. You want to smash the two together? Throw information into one and panic when you cannot get it back. They are the ultimate laboratory, but the lab is padlocked behind a wall of infinite gravity. Scientists are left piecing together clues from the edges. It is like being given the crumbs of the universe's weirdest cake and asked to reverse engineer the recipe. And then there is the human obsession with survival. People ask, could you live near a black hole? In theory, yes, if you kept a respectful distance. You could even orbit one safely, though your view would be distorted by gravitational lensing. The sky would twist and warp, stars bending into arcs of light. It would be beautiful until you wandered too close and got stretched into space spaghetti. The vacation brochure leaves that part out. Of course, our species is not just curious, we are reckless. Some scientists have worried that particle colliders might accidentally create microscopic black holes. Do not panic. If that ever happened, they would evaporate instantly thanks to Hawking radiation. Still, the fact that humanity built machines where that question was not entirely absurd tells you something about our priorities. What black holes really teach us is humility. They are reminders that the universe is not designed for our comfort. The rules we live by on Earth collapse at their borders. Cause and effect, time and space, even the fate of information itself, all come under review. Every discovery about them only deepens the mystery. The closer we get, the less sense it makes, like chasing a horizon that keeps retreating. And yet, maybe that is the point. Black holes are not here to give us answers, neatly wrapped in equations. They are here to remind us that nature is bigger, stranger, and funnier than our imaginations. They are the cosmic equivalent of a practical joke that also happens to hold the key to unifying physics. So the next time you think of black holes, picture less of a vacuum cleaner and more of a cosmic trickster, an object that erases itself from view while shaping everything around it. That plays hide and seek with light, time, and matter. That holds the secrets of creation and destruction in one compact, terrifying package. Because at the end of the day, black holes are not just holes. They are mirrors. They reflect the limits of our knowledge, the fragility of our theories, and the audacity of a universe that refuses to make sense just to please us. And maybe that is the most fascinating secret of all.